Hi students, in this week's video we're going to do integration, so do get ready a pen and some papers and practice along with me. What is integration? Integration basically is just the reverse process of differentiation. Let's look at some examples. If we are asked to differentiate x cubed plus 1, what do we get? Yes, we get 3x squared. And I'm going to add the integral signs to both sides. And I'm going to multiply the x on both sides. And since I'm finding the integral of x squared dx, I'm going to shift it to my left hand side and extracting 3 out from it. And because integration and differentiation is the opposite of each other, that means when you differentiate something and you integrate it, you get back what you're supposed to be getting at. So you can just cancel off the differentiation and integration. That's a definition. That's a definition of integration. So we're just using the definition to explain why we can just cancel the f and the d. Right, and you're going to divide by 3 on both sides. So the integrations of x squared with respect to dx is x cubed over 3 plus 1/3. So if you think about it, if I'm going to ask you to differentiate x cubed over 3, what do you get? If you differentiate x cubed over 3 plus 1/3, you get 3x squared over 3 plus 0, right? Because you differentiate 1/3, you get 0. So 3x squared over 3 will give you x squared, which is what we're supposed to be finding, the integral. Let's look at another example. When you differentiate x cubed plus 3, what do you get? Yes, you get 3x squared. And I'm going to add the integration sign to both sides. Do the same process again. Shift whatever that's on the, just shift the position, whatever that's on the right, just put the whole thing on the left, and whatever that's on the left, put it on the right. Okay, and then f and d, a definition is the reverse of each other. We can just cancel it off and just divide by 3 on both sides, and this is what you get. Right, so if by observations you will see that if you want to integrate, let's say x to the power of n dx, right, you will see that from these examples that we have done, basically what we have done is just getting this power plus 1 gives you 3, and then divide by the power. Right, and if you look at what we have here, there's a constant here, because when we differentiate a constant, you get 0. So when we reverse the process, right, there's a possibility there's a constant there. We wouldn't know. Therefore, we must always, after finding the this is called the indefinite integral. So after integrating it, you have to add a constant to it. Okay, due to these cases. If you don't quite get it, let's see, for example, if I'm going to differentiate x cubed plus 4, differentiate it, you get 3x squared. Right? But there's a constant 4 there, right? It's just that when you differentiate constant, you get 0. So therefore, when you reverse the process, all right, there's a possibility of a constant there. So therefore, you need to add a plus c. Okay? Right, we're going to extend this to what happens if you're going to integrate. Yes, bracket ax plus b to the power n. So it's still the same. You just zoom into the power. Whatever you're given, whatever you're given, you just write it down. Zoom into the power plus 1. Divide by the power, but there's one extra step there. Where does the a come from? Yes, the a is actually the differentiation of whatever that's inside your brackets. You differentiate ax plus b, that gives you a. So this is an extra step. For example, if I ask to integrate 2x plus 3 to the power of 4 dx, then what you get is 2x plus 3 to the power of 5 4 plus 1 is 5, divide by 5 times the differentiation of whatever is at the bracket. So differentiate 2x plus 3, you get 2. So you will get bracket 2x plus 3 to the power of 5 over 10 plus a constant c. Right. Okay, let's look at basic questions. Okay, so let's write down what we have learned so far. So we learned that the integral of x to the power n dx will gives you x to the power n plus 1 over n plus 1 plus c, right? Right, so I'm going to show you but how we're going to do e squared. E squared is a constant. So we can actually write e squared as e squared times x to the power of 0. Alright, so e is a constant, e squared is a constant, we can just take it out of the integral sign, we don't have to bother with it. Okay, and then you will see that this is the one we need to work on it. So 0 plus 1 will give you 1 divided by 1. So what you're getting is e squared x plus e. Excuse me. Right, so if you were to do the reverse process, what we are saying is that when you differentiate e squared x, right, when you differentiate e squared x, what do I get? You get e squared, right? So when you integrate e squared, I'll get e squared x plus a constant. Okay, so this is how you do it. This is the process why we get e squared x. But if you have to think of it as a reverse process, you actually don't have to go through all these steps, right? Right, if you look at b, very quickly you'll be able to tell me the integrations of 1/3 the x is just 1/3 x plus c, right? However, if you still don't get it, I will show it again the steps. You can write 1/3 as 1/3 times x to the power of 0, and then this one plus 1, so that gives you x to the power 1 over 1. So it's 1/3 times x to the power 1 over 1, right? But if you think of it as a reverse process, you don't have to go through all these steps, right? You'll be very quickly tell me that yes, the integrations of 1/3 the x is just 1/3 x plus c. Okay, let's look at part C. Alright, look at part C. So 2x ln 3. 2x ln 3, you can actually write it as 2 ln 3x. Because ln 3 is a constant. 2 is a constant. So 2 ln 3 will give you a constant, right? So you can actually just pull it out. Pull your 2 ln 3 out from your integral. And then you just integrate x. So x is x to the power 1, right? So you just take the power plus 1 then divide by 2. Right. Simplified it. Okay. It looks better with if you bracket it ln 3. Let's look at d. 1 over pi is a constant. Right. Basically 1 over pi is a constant. So what will you get if you think of it in reverse? Yes, you integrate 1 over pi, you just get 1 over pi x plus c. Okay, but I'll just show you the steps again. It means, yeah, it means it's 1 over pi times 1, right? 1 over pi times 1 gives you 1 over pi. You just take out 1 over pi, and then x is, you can just, this 1 here, you can just write it as x to the power of 0. This will give you x to the power of 0. And then you just take 0 plus 1 to give you x to the power 1 over 1. And x to the power 1 over 1 is just x. So that explained here. But if you think of it as a reverse, you don't have to go through all these steps, right? Because when you differentiate 1 over pi x, it will just give you 1 over pi. So when you integrate 1 over pi, you just get 1 over pi x plus c. Okay, let's go on to e. So 2e, you see, is a constant. Okay, you can just use a calculator to find the values. E to the power 1 times 2 is a constant. So you can just put it out from your integral sign. And you just integrate x. So integrate x will be just x squared over 2. Right, and then you simplify it, you get ex squared plus c. Let's look at f. So ln 4 is a constant, just pull it out. And then this power plus 1 gives you 4, then divide by 4. Simplify it. Okay, that's how you do it. Okay. All right, let's look at question 5. But before we look at question 5, there's some kind of basic concepts that you need to recall. And what is it? Yes, a over x to the power n can be written as ax to the power negative n. It's very important. You must be well versed in able to convert positive index to negative index. Likewise, negative index to positive index. Okay, this is very important when you are dealing with this topic on integrations and differentiation. All right, so if we look at 5a, we have done something like that. In the chapter of differentiation, we need to simplify it first, right? Because basically the formula to integrate x to the power n dx, you have to write it as x to the power of something before you can actually apply it, right? So therefore, I need to simplify this expression. So how do I simplify it? Yes, you can actually break it up into two fractions, and that will give you 2 plus. Okay, so this is what I mean by you must be able to apply this rule here, able to write it as a negative index. So that gives you 3x power negative 2. So we're going to integrate each term. So integrate 2, right? Think of it, integrate 2, what do you get? Yes, you get 2x. Because differentiate 2x, you get 2. Integrate 2, you get 2x. Okay, and this one, you need to do some working. All right, you can just use a calculator. Don't have to write down the steps. It's very confusing. Like negative 2 plus 1, don't need to. Just use a calculator, put negative 2 plus 1. That will give you negative 1. So straight away write down the answer for the power. Okay, don't write extra steps. The more you write, the more mistake you may make. Unnecessary step, I'm not saying necessary. Necessary step you have to, unnecessary don't need to. Just use a calculator. Negative 2 plus 1 gives you negative 1 divided by negative 1. Okay, and of course you need to simplify further. All right, so how do I end up there? Right, so positive with a negative will give you a negative, right? So what we have is 3 times x to the power negative 1. So remember we say that you must be able to convert from negative index to positive. Okay, so that's how I get 3 over x. Let's look at part B. I'm going to do the same, separate it into 2 separate fractions. Okay, if you are not using this method like what I've done, some of you prefer to do it this way, then you have to watch out. What do I mean by watch out? You have to bracket this whole thing, bracket it. You need to bracket it. Okay, because if you don't bracket it right, some of you may end up getting the wrong answer. Some of you may do like this. And that's wrong. Because what we have here is actually divide by 2. Something divide by 2. Not something times 2. What you have here is times 2, which is wrong because it is not times 2, it's divide by 2. So if you are used, if you like to convert it, in this method, in this way, then make sure you bracket the whole thing. That will remind you that you're actually having 2 to the power negative 1. You're actually having half and not 2. Otherwise, I always prefer to just do it separately. Separately, you don't have the problem. You just do it separately, and you end up getting a half for the first term. Second term is half times x to the power negative 2. All right, so we're going to integrate it. So integrate half, you get half x. Okay, and this one, you just use your calculator. Negative 2 plus 1 gives you negative 1. Divide by negative 1. Simplify it. and plus C. It's very important. You need to plus C. The plus C will cost you 1 mark if you don't put it there. Alright, so the next question is basically just, yes, we'll be using this formula. Okay, right. So let's look at part A. Right, so whatever you have, you just have to write it down. That means you have 3x plus 1. Just write it down and then zoom into the power at 1. That gives you 5. Divide by 5 times differentiate whatever that's inside the bracket. That gives you 3. So this is what we have. And of course, not to forget, you need to plus C. Okay, you can actually write it as in this way, or you can just leave it as this over 15 plus C. Okay, I don't think the marker will fault you for writing that. It's just that I pull out 1 over 15 as the coefficient. Okay, let's look at part B. So likewise, what you get is bracket 1 minus x, but it's to the power of 4 divided by 4. And then yes, where do I get negative 1? Because when you differentiate these two terms here, differentiate 1, you get 0. Differentiate negative x, you get negative 1. Simplify it. Okay, and as like what I've mentioned earlier, if you don't want to pull out your negative 1/4, you can just leave it as negative bracket 1 minus x to the power of 4 over 4 plus c. Okay, right, let's look at part C. Okay, so negative 3 plus 1 gives you negative 2. Divide by negative 2, differentiate this one, you get 2. You simplify it. Okay, this is what you get. Okay, so for this question, it's very tricky. Why tricky? Because it's related to the earlier chapter we have done. And if you're not careful, right, if you're not careful, you will end up not knowing what to do. Because basically, we don't have a quotient rule for integrations or product rule for integration at this level that we're learning. At this level that we're learning, we only learn 2 simple rules. So whatever we have learned at this juncture, we have to apply what we have learned and not anything else. That means you're not to come up with your own rule. So basically, this is what we have learned so far. Okay, so we need to apply just these 2 rules only. So if you look at what you have there, basically you cannot apply any of these 2 rules we have learned, right? It must be x to the power of something. So therefore, you have to think deeper. You have to ask yourself, have I seen something like this before on the earlier chapters you have learned? Yes, in the chapter on polynomial, this is called an improper fraction because your power of your numerator is equal to the power of your denominator or more. It's called improper fraction. And what do we do with improper fraction? Yes, we have to apply the long division method, right? To break it up into quotient plus remainder over divisor. Okay, so this one you can write it as if you've forgotten how to do it. You can just go back and revisit your polynomial chapter on polynomial, look at the past videos I've done, or if you were to recall, we have learned something like that in primary school. You can actually write 5 divided by 2 as 2 plus half, or 2.5, right? So therefore, this improper fraction can be written as 1, quotient that's 1, minus is plus, but the remainder is negative. So plus times negative will give you a negative. It's actually 1 plus your remainder over your divisor, right? Okay, but your remainder is negative 1. So positive times negative 1 gives you negative. Okay, and if you were to examine the denominator carefully, you see that I can factorize it into a repeated linear factors. Okay, and then I can write it as a negative index. And I can just apply the rule that we've learned. Okay, so we can just integrate it, right? Simplify it, okay? Right, so this question is similar in nature to the earlier question. Okay, you will observe that it is an improper fraction because power of your numerator is equal to the power of a denominator. So we have to apply long division. And it's a bit tricky, right? It's a bit tricky because you see that the coefficients of x squared is 9, right? It's bigger than the coefficients of your dividend 3. So you will have to take 9 times 1/3 to get 3. And then you just have to be a bit careful lah. This one will end up 4/3. Okay, so your remainder is actually negative 4/3. So if you're going to write it as what we have done in the earlier questions, quotient plus remainder over divisor. Okay, so this is what you get. All right, and then how do I end up this step? Is basically you can just apply the trick that I've been using all this while. Look out for this denominator times 3 times 3. So 4/3 times 3 will just give you 4, and then put the 3 in front. And then just pull out your, this one will give you 4 over 3 times 1 over bracket 3x minus 2 to the power of 2. Then convert this into negative index. And how do I get bracket 3x minus 2? We just factorize this guy. Factorize it. Okay, you can use your calculator to help you get the linear factors, or if you like, you can just do, this whatever, call it the box method or whatever. You can just use a calculator. Okay, using a calculator is easier lah, to just help you get your linear factor. Right, so it's actually a repeated factors. All right, so now we can integrate it. So integrate 1/3, you get 1/3 x. Okay, and this will give us negative 2 plus 1. This will be negative 2 plus 1 gives you negative 1. Divide by negative 1, and not to forget to differentiate whatever is inside the bracket. This is one step that a lot of students will tend to forget. Okay, so you have to find some way to remember it lah. Just always look back at the bracket. Okay, just remember, make friends with the bracket. Brackets are very important. Okay, and then yeah, that's it. That's the answer. I've shown you every step clearly, so you can just follow the steps. Alright, so question 11 is relatively easy. You're told that a is a constant. So if a is a constant, basically 3a squared is a constant, so you can just pull it out from the integral sign. Right, and then you convert your square root x, this radical form, into index form. This is x to the power 1/3. And you just apply this basic rule to find your integrations, integral for x to the power n. Okay, so it'll be half plus 1. So it's difficult because there's some algebra involved in it. Okay, so I'm going to explain how I end up this. So what you have is you just take your calculator, half plus 1, that gives you 3/2, right? So you're supposed to divide by 3/2, isn't it? Right, so you think of it this way, 3/2, if you times 2 times 2, you end up 2x to the power 3/2/3, right? So you don't have to write these steps. But if you want to, if you're scared that you make mistake, just go ahead. Otherwise, can you see when you flip 1 divide by 3/2, you just flip it. 1 divide by 3/2, flip it, you'll get 2/3. So for x to the power 1/3, likewise, x to the power 1/3. Okay, if you use a calculator, 1/3 plus 1 will gives you 4/3. So it's supposed to divide by 4/3, right? So you flip it. Okay, you flip it, you just get 3x power 4/3/4. This is what it means. Okay, and then not to forget, you need to add a constancy. Of course, then open up the bracket lah. Simplify it, open up the bracket. Okay. Right, so let's do a recap. If you have like x to the power 5/3 divided by 5/3, what you get is 3x to the power 5/3/5. So whatever you have here, can you see, is just the flip of your 5/3. Right, if you look at question 12, there are 2 parts. This kind of question is very popular in the exams. Okay, very popular. It actually combines differentiation with integration. And of course, it makes sense because integration is the reverse process of differentiation. So it kind of makes sense to actually set this kind of questions. So for part I, basically just using the quotient rule. But some of you, if you prefer to go ahead and use product rule, how do you use product rule in this, which I don't quite, some of you like to do it that way, you just go ahead and do it. You basically convert it into this format. And then you want to apply product rule, go ahead. But I just follow by the rule. If they give me a fraction, I just use quotient rule. So I let the numerator be u, denominator be v, and then I find the u over dx to be 2x. And the v over dx will have more steps. Okay, because it's basically 4x minus 5 to the power half. So you have to bring out the half, right? Half minus 1 gives you negative half times. Always look inside the bracket. Always look inside the bracket times the differentiation of 4x minus 5. That gives you times 4. And then convert it into positive index. Okay, right. And then write down the quotient rule. Okay, and right, I'm going to use the trick that I've been always using. Look at your denominator. So I'm just going to multiply with square root 4x minus 5 at the numerator, also at the denominator. So this is what I'll get. So just multiply this term here. So your square root will be gone. Square root 4x minus 5 times square root 4x minus 5. And make sure you bracket it. A lot of time you forget to bracket this. Bracket it times 2x. And of course, the other term just cancel off the square root 4x minus 5 to just give you negative 2x squared. And how I end up 3/2? Because this is to the power 1, right? And this is to the power of half. So 1 plus half will give you 3/2. So basically, and then you simplify the numerator, and this is what you're supposed to show in part I. Okay? So at the next slide, we'll do part 2. Alright, so we're going to use what we have found in part I to do part 2. We're going to use hence. And it's kind of logical to use hence because you remember that differentiation is the opposite of integration, that kind of thing. So we're going to make use of differentiation to find our integrations for 3x squared minus 5x over bracket 4x minus 5 to the power of 3/2. Alright, so we start off by writing this. And if you were to remember the first slides that I've shown you, okay, how we actually make use of how we actually go through the integration and the differentiation reverse process. You add integral to both sides, right? And then we multiply by dx on both sides, right? To get this. And then we mention things like differentiation, integration opposite each other, cancel all this, okay? Right, and then the next step is, if you look at it carefully, right, 6x squared minus 10x, I can actually factorize my 2 out. Factorize, take out the 2, pull it out of the integral sign to get 3x squared minus 5x over Alright, and do you know why I want to take out the 2 from the numerator? Yes, if you look at what you're supposed to find here, can you see that what I want for my numerator is 3x squared minus 5x. 3x squared minus 5x. That's why I need to pull out. From here, I need to pull out the 2 so that I get exactly what is required here. Okay, then I need to get rid of my 2, right? So how do you get rid of the 2? Right, you can divide by 2 on both sides. But instead of dividing by 2 on both sides, it's the same as times half, right? Because 2 times half gives you 1. So I times half on both sides. Dividing by 2 is the same as times half. Okay? So what I would end up with would be exactly what I'm required to do for the questions. And of course, not to forget our plus C, very important. Okay, so this is how we do it. And for this part of the question, I think it's about 3 or 4 marks in the exam. All right, let's look at question 15. This is a rather long assignment, so don't give up, okay? And if you feel like you can't take it anymore, just take a short break, have a Kit Kat, stretch a bit, okay, before you continue, because it's very long. All right, so what we are having here is a curve y equals to f of x. Second derivative, you're given second derivative d2y over the x squared equals to 1 minus x squared. That's why it's connected to differentiation. So you must be good in differentiation. Otherwise, if you are not good in differentiation, integration will suffer. And if your differentiation, integration suffer, your kinematics will suffer. Okay, so all these are all related. So if you're not too sure about differentiation, go and revisit the chapter first before you come to integration. Okay, so you're given that equations of a tangent to the curve at a particular point is y equals to 5 minus x. Find the equations of the curve. All right, so if you can actually have a diagram. You can always start off with the diagram, just a curve. And then at this particular curve, you have a point 1, 4, right? And then you have a tangent. Okay, and the equations of this tangent is y equals to 5 minus x. Right, so he asked to find the equations of the curve. So always remember that the integration is opposite of differentiation, right? So if you're given y equals to something, when you differentiate it, you get dy over dx, right? Equals to something. So when I integrate it, I'll get back my y plus c. So if I'm given dy over dx equals to something, I differentiate it, I'll get d2y over dx squared equals to something, right? So if I reverse the process, that means if I integrate your d2y over dx squared, what you're getting is your dy over dx plus c. Can you see the process? So therefore, when I'm going to integrate my d2y over dx squared, what I'm getting is dy over dx. Okay? Let me repeat. When I integrate my d2y over dx squared, I get my dy over dx. Of course, when you do integration on the left, also must do integration on the right lah. Okay, then I'm going to integrate this. And what do I get? Right. And I need to find the constant c, right? So how do we go about finding the constant c? Yes, you are told that there's a particular point, okay, as what I've drawn, but here I drew it again. So the gradient is -1, and this -1 is actually your dy dx. If you were to recall back how we go about solving tangent line, gradient function, dy dx is a gradient function, right? And when I substitute x equals to 1, I get the gradient -1. Right, so basically your dy dx is your -1. So you sub into it to get your constant c. So your dy dx, your gradient function is x minus 1/3 x cubed minus 5/3. But we need to find the equations of a curve, which is y equals to something. So I need to integrate it again. So when I integrate my dy dx, I'll get y. And of course, integrate left also must integrate right, right? End up with another constant. So how do we find the constant? Yes, you basically just substitute the point 1,4 inside to find your c, and then that is your equation. So let's do a repeat. Let's do a summary of this kind of questions. Right, so basically, okay, the arrow goes this way. If you're given y equals to something, you differentiate it, you get dy over dx equals to something, right? You differentiate it again, you get the 2y over dx squared equals to something, right? So now you reverse the process. You reverse. You integrate it. You integrate your d2y over dx squared, you get your dy over dx. You integrate your dy over dx, you get your y, then plus c. Of course, it's also plus c. Okay? All right, question 16, it's similar in nature to question 15, except that in this case here, you are told that it has a minimum point at 1,5. Right, so if you recall, if you have a curve that has a maximum minimum point, basically a stationary point, what do you know about the gradient function? That's the question you need to ask yourself. If a curve has a stationary point, it could be minimum or point of inflection. What do you know about the gradient function? Yes, the gradient functions will be equals to 0, right? This part of the information tells us that my gradient function will be equals to 0, right? Okay, so we use the concept we've learned earlier on. You integrate the 2y over the x squared, you should get your dy over the x. And of course, integrate left also must integrate right lah. So you integrate 6x, you get 6x squared over 2. Integrate 4, you get 4x plus a constant c. So how do I find the constant c? Okay, this is exactly where the piece of information comes in. You're told that it's at a minimum point at 1,5, and minimum maximum point is when the dy dx equals to 0. Okay, right. So we asked to find the equations to the curve. Equation to the curve is y equals to something, so I need to integrate one more time, right? So when integrate dy over dx, I get my y plus c. And how do I find the unknown c? Yes, you're given the point already 1,5. Basically, that 1,5 lies on the curve. So you can substitute into it to find your c. And that's how you get the equations of the curve. That's for part I. Okay, so how about part 2? Yes, so for part 2, remember what we have in part I. In part I, we found our dy over dx equals to 3x squared minus 4x plus c, right? We don't need to differentiate it one more time. I know you have the equations of the curve. Some of you will just go and differentiate it one more time. If you want to do it, go ahead. If not, you can just reuse your dy over dx you found earlier, and then just substitute the values of c. You found your c to be 1, right? You can just put it in your c. Otherwise, let me repeat. If you're happy enough to go and differentiate the y again to get 3x squared minus 4x plus 1, go ahead. All right, so to find maximum minimum value, what do we do? Yes, we let dy over dx equals to 0, right? That's the concept, right? And then you factorize your 3x squared minus 4x plus 1. You get 2 points. One of them is the one that's given to us, remember? We are given that x equals to 1, 5 is the minimum point. So that's the one given. So the other one, x equals to 1/3, is the other stationary point. Right, so we need to determine, because it says find the maximum value, so we need to make sure that x equals to 1/3 is actually the maximum point. So you substitute x equals to 1/3 into your d2 y over dx squared, and you get a negative value. So therefore x equals to 1/3 will give a maximum value. Okay, so we substitute into your y, equations of the y we found earlier on. So the maximum value of y is 4 over 27. So these questions involve the concepts we've learned earlier on maximum, minimum point, the kind of thing. All right, so let me repeat all these 2 chapters. In fact, 3 goals, so they're all related. So you need to learn your differentiation well, okay, before you tackle your integration. Right, so if you look at question 20, this is what I mean. Question 20 is related to your rate of change. And rate of change is a topic you learn in differentiation. Okay, so if you look at question 30, you have a water, all right, being pumped into a rubber sphere at the rate of 2 centimeter cube per second. And after 10 seconds, we pump water inside, of course, your sphere will get bigger and bigger, right? So the volume becomes 150 cm cube after 10 seconds. Find part I, an expression for the volume of the sphere in terms of T. Okay? Right, so you're given dV over dt equals to 2 centimeter cube. You can't use 4/3 pi cube because you don't know what's the radius. And you're supposed to also express your answer in terms of T, not in terms of R. So you have to work on what you are being told. You're told that the rate of change of the volume is 2 centimeter cube per second. So how do you get volume from your dV over dt? Remember how we get y from your dy over dx? You need to integrate dy over dx to get y, right? You need to integrate the squared y over the x squared to get dy over dx. So likewise, if you want to find volume, you need to integrate your dv over dt to get your v, right? So this is exactly what we're going to do. So the concepts of integration is the reverse of differentiation, or integration is the reverse of differentiation. Is very important. You must understand the concept. Okay, so you can just, how do you end up like that? Integrate 2, you get 2t. So that's what I mean by this thing is very important. It can be respect to dt or dv. It depends on this guy here. If what you are having, example, if what you're having is dz over df, let's say, then when you integrate it is respect to df. Okay, something here. So it's important. All right, so here we are actually integrating respect to dt because of what we have here. Integrate 2, you get 2t, not 2x. You're integrating respect to dt, so it's 2t plus a constant, and this cancel off each other, right? It's the reverse of each other. Okay, so I need to find the constant c. How do we find the constant c? So this is where this piece of information comes in. The volume is 150 at t equals to 10. So you can substitute in to find your c. Right, so you can find your expression for your volume. So this is part I. Okay, part 2, find this radius of the sphere after 2 seconds. So this is our formula, right? And what is another formula to find volume of a sphere? Oh, at 2 seconds, sorry. So we can find the volume first. Yes, so we let the radius be r. What is another formula to find volume of a sphere? Is, you're right, 4 third pi r cube, which we cannot use it earlier on just now because we don't know the radius. Now we know the volume at 2 seconds is 130. We can just equate it. Okay, times 3 throughout. Then divide by 4 pi. Then cube root it. And you get 3.17 cm. My goodness, this question is really long and stinky, man. So the 4 parts of the question. Okay, so we have just done part I and part 2. So part 3 is find the rate of change of the radius. So it's connected to your rate of change, right? Rate of change of the radius. That means we're finding the r over dt. So you need to form your connected rate of change. So the r over dt is the r over dv times dv over dt. So this guy we know already early on, right? We're given 2 centimeter cube, right? That is your 2. This is the one that we need to find. And how will we find that? Yes, it's from your part 2. We got the formula for your volume of your sphere, right? Which is 4 third pi r cube, right? So we just find dv over dr. Okay, I prefer, a lot of you just leave it as 4 pi r squared, then sub inside here. I prefer to sub radius equals to 2 first. No, radius, what the radius we found earlier on, I can't remember what is it. I prefer to go and find the physical value for dv over dr before I sub into my connected rate of change. Yes, the radius we found earlier was 3.174. Don't use 3.17. For better accuracy, you should use one with more decimal places, more significant figure. Then sub in your dv over dr. Okay, I prefer to do that. And then after that, you just flip it because you want the r over dv. So it's easier. You likelihood of making mistake is lesser. Likelihood of making mistake is lessened. Likelihood of making mistake is lesser. Okay, never mind, forget it. I'm not English teacher. Okay, so therefore the rate of change of the radius of sphere is 0.015. 3 significant figure, centimeter per second. Okay. Alright, finally part 4. Okay, as if it's not okay, never mind. So it's alright, this question is very good. It tests you on rate of change and differentiation integration. Fantastic. So for part 4, you're asked to find the rate of change of the surface area. Okay, so this is what we found earlier on. We at t equals to 2 seconds, we found radius to be 3.174. What is the formula to find surface area of a sphere? Do you remember? Right, the surface area be A. Yes, the surface area of a sphere is 4 pi r squared. Why do you think I need to find the A over the R? Yes, because to find the rate of change of your surface area is the A over dt, right? So the A over dt will be equals to, oh yeah, I'm very kiasu lah. I find the values for the A over the R first lah. Then that's why the connected rate of change, yes. You see, this is what I mean. Surely I will need this guy. That's why you see, I'm thinking ahead. Okay. Right, so now we can plug the values in and put it to 3 significant figure. So the rate of change of your surface area at t equals to 2 seconds is 1.26 centimeters squared per second. Right, so finally we have come to the last question. Question 22. So please congratulate yourself. Okay, this is a very, very long and tedious assignment. So you've managed to stay throughout. It's really a spirit of perseverance. Right, 22 part A and part B, you're asked to prove if the information is given there, whether is it true or not. If it's not true, then give a counter example. Alright, so that's what we're going to do. We're going to let f of x be 2, be x, g of x be 2. Alright, so we are going to multiply them together to get 2x. Integrate it, you will get x squared plus c. And then we're going to integrate it separately as what we are told to do. Integrate it separately. Integrate f of x first times integrate g of x. So you integrate x, you get x squared over 2 plus a constant c1. There are two different integration here, two different functions, so you cannot use the same symbol for the constant. So the first constant I use c1, second constant I use c2. And then they expand it. And quite obviously, right, x squared plus c will not be equals to this very complicated expression here, right? Right, so the answer is no, they are not. It is false. They are not equal to each other. So you can do the same for part B. Right, so we're going to use the same expressions we've used earlier on. Let f of x be x, u of x be 2. Okay. Work through the same process. You will have integrations of x over 2, pull out the half, integrate x, you get x squared over 2. So you end up with 1/4 x squared plus c. Alright, and then do the same for the right hand side. Integrate it separately. Okay, you end up getting 1/4 x plus c, so they are not the same. So no, it is not true. They are not equal again. So what is the rationale of having 22? The rationale of having 22 is to caution you, okay, that you cannot simply apply your own rule. Okay, there's no such thing as when you integrate f of x divided by g of x give you integrate f of x over g of x. Okay, this is a very good question to remind you. You cannot anyhow provide your own rules. Okay, you have to use the rule that we have learned. All right, you cannot invent your own rules unless it is a recognized one. Okay, so happy learning.